Good evening, everybody. My name is Bob Lowe. I'm the director of the Energy Group there. So for years, I was the deputy director until just a few months ago. It is my enormous pleasure this evening to introduce Dr. Craig Robertson, who will be giving a talk on influencing design through building performance feedback, which seems to me to be an incredibly important topic. But before we get on to that, I would like to just run through the housekeeping concerning stuff. So, fire exits at the back, immediately behind you, but run out through the door. You escape directly into the street behind you. If, for any reason, that's impossible, then there are alternative exits in the opposite direction. The structure of the event is going to be 45 minutes roughly of talk about guests this evening, followed by questions, which I will let run until it's clear that the questions are stopping, or until the speaker himself is so exhausted that we can't stop. We will then adjourn to the drawing room upstairs, Harry's kitchen, where we will have refreshments and I hope further informal conversations until about 7:30. Now, normally at this point, I tell you how difficult it is to get out of the building after 7 o'clock. Happily, that doesn't apply this evening. There will be somebody on the door until 8 o'clock this evening. But we will try to throw you out before 8 o'clock so that everybody can get home not too late. If I can just say a few more words now about Craig before we start. He is an architect and researcher, and is Allford or Monaghan Morris Architect Sustainability Specialist. Interestingly, he gained this post as a direct result of his PhD. So those of you, in particular those students in the year who are wondering whether they will be employable after having done a PhD, the answer in at least one case, you will understand the limits of case studies, is yes, you will be employable. Craig was not employed despite, but because of his PhD. His talk is based on his PhD, the learnings from which he is now in the process of implementing at Allford or Monaghan Morris, where he works. Though on a wider front, so, Craig, over to you.
Thank you very much. Thanks for coming, everybody. Do you want to, there's a few seats down here if you want to come down in front. Thank you very much for inviting me here. Apologies for the slightly grandad holiday snaps projector on the table. I think it's something I've put on hanging from the ceiling. As Bob said, I have recently finished my PhD at the Energy Institute at the start of this year, and I've since been working since January at AHMM, where I'm implementing some of the outcomes of that. I'm going to talk about the structure of this talk in a second, but first of all, I thought I would show. We failed the first hurdle. The clickers stopped clicking. So this is a piece of UCL equipment. I don't know. Is the guy still? Wait a minute. Okay, here we go. Thank you. Right, so I thought I'd start with a big crunch of text. This is some quotes from the recent IPCC report that came out last week, and I've included this because over the last decade or so that I've been writing and talking about implementing energy reduction measures in architecture, the IPCC have occasionally been updating reports, and the unequivocalness of their statements is increasing and increasing, and now surely we are at the point where we stop having to have conversations about why we need to do this, and we can just get on with talking about what we're going to do about it. So on that basis, I've omitted any justification of why we're doing this. I'm just talking about what we're going to do about it. I hope we're all on board with that. So the structure of this talk is, as Bob said, around my PhD. Quick introduction about why I'm interested in this, and then my PhD title is Role of Energy Information Feedback in Design and Construction Practice. I'll talk about just some headline findings from that, and what they meant for well, exactly that, the role of energy information feedback in design and construction practice. And now I'm going to talk about the Allford and Morris Sustainability Toolkit, which is a long-running piece of guidance and an in-house way of reviewing our projects, but how we're now implementing some performance evaluation to feed directly into that toolkit to inform our design process and make our buildings better, implement some of the direct findings from my PhD. First of all, I thought I'd start with one of my favourite buildings. I wondered if anybody knew what this was and what it's got a very particular performance metric which I like a lot. Anybody recognise this? This performance metric? Paul?
Is it an ice house?
It is. Its performance metric is salmon, fish. So I like the elegance of smelling your building not working. That's quite a nice thing. So that ice house is in Brora. Brora is a very small village about 60 kilometres south of John O'Groats on the north-east coast of Sutherland in the Highlands. It sits on the mouth of the River Brora, about 6 kilometres away from Loch Brora. Loch Brora used to freeze over every winter. Ice would be cut from the loch, floated down the river, lifted into the ice house, and through some very simple building physics, aided by a highland climate, fish was kept fresh all year round. I like that building because of the simplicity, the elegance of the building physics, the legibility of the design. It's there, you know exactly what's happening with that building. And I can imagine an empirical process that went into the design of that building. There's information, very pungent information, rotting fish, told you that the building wasn't working properly, people amended it. They probably only got it wrong once because they were very hungry when they got it wrong, but they amended their design, made it work better, and it's functioning. Other examples of this are obviously the Casbah in North Africa. This is in Morocco, in the foothills of the Alps. Thermally massive building, low apertures, ventilation stacks in the corners, perhaps some evaporative cooling in the middle. Again, there's an empirical design process, some research and development has gone into the development of that design, possibly based on what other people are doing, exchanging of information, generations of information, design expertise being passed down to make buildings better. What I'm interested in is a process that we can gather information from existing buildings, our buildings, and apply this knowledge and understanding in a way that improves our process. Final example I'm going to show is this building, because this is the kind of tropics version of the Casbah, but this is Jean Prouvé's Maison Tropicale, so this is a modern or relatively modern take on a vernacular. And I'm showing this when it was in London outside Tate Modern, so it's quite a nice incongruity between the grey London sky and Maison Tropicale, which amuses me anyway. But this is somebody, Jean Prouvé was a industrial designer. The problem was French colonials needing accommodation in the tropics. He was asked to design some houses. He didn't design houses, he just stole the generational research and development that had been happening in that region and applied modern construction methods to it. So it's that empirical process of learning from what's happened before, applying it to a modern building in a way that meets construction methods, standards that you're trying to make. I think that's a good example of that, and it's what my PhD was about. Learning from what's happened in the past, specifically energy. How can we take information, energy metering information out of buildings with some supporting building characteristic information, systems information, and apply it to new designs? I said I wasn't going to show any justification for why we're doing this. I'm not. I'm only showing this slide because of the bottom bullet point. The point is that we are charged as a building industry, we're charged with delivering these reductions in CO2 emissions and energy consumption in buildings via a complex web of guidance, legislation, certification, financial incentive, and other mechanisms that are often contradictory, often fighting against each other, often apply to different people. And the investigation of my PhD was looking at how these affect decisions and how they affect subsequent energy consumption. These are 3 quotes which I like. Some of them are old. There's one from Harry Bruns which is a decade old, but it is still relevant. To say Harry Bruns was my original PhD supervisor for a day I'm on which took over. The top is from Dave of London South Bank University. It could be from a number of people he has identified along with lots of other people, but this web of regulation legislation has reduced the anticipated energy consumption of buildings rather than the actual consumption of any buildings. So the performance gap that we're all familiar now, and which Carbon Buzz and other platforms have been trying to address for some years now. Second, Harry Bruns in 2004 identified that the problems with energy performance is a lack of information and a lack of effective use of information that we do have. I would say in the last decade, we probably have lots of information now, but we are still not making effective use of it. So it's become much easier to gather information, to collect information. The technology of metering and remotely accessing data is there. We have lots of it. We're not making effective use of it. And finally, a board scope, which could be from a number of Billboard papers, feedback about feeding knowledge of outputs back into inputs in order to improve outcomes. To go to the ice house, does my fish smell? Yes. Put more air up on the roof. My fish know what it smells. So this was used to frame some research questions, which I have written down for you to look at. My PhD was based on, first was looking at the context, kind of defining that context for decision making, so formalising those contextual pressures, as I call them. Second was looking at how they influence people's decision making. Do they actually influence how people think about energy, how they engage with energy feedback, or how they might look at using energy feedback in their design process. Third, looked at the potential for crowdsourcing to provide this information feedback. And fourth was the kind of relationship between contextual pressures, people's interactions, actors' interactions with that, and the outcomes of energy, and then some recommendations for how that might be changed or improved. So, a methodology was made. It's a mixed methodology in 3 phases. The first defined the contextual pressures, which I'll talk about in a minute, through a literature review and some participant observation. The participant observation was my involvement in the early stage development of Carbon Buzz, which is a RRD, it's simply an industry-backed platform looking at the performance gap design and actual information, aiming to encourage people to look at evidence from existing buildings to produce better predictions of energy consumption. The second phase was in 3 phases of empirical data collection. The Carbon Buzz database itself, 3 years worth of information. A survey, an industry survey, that went out to about 500 industry actors, and then a series of interviews with actors. 5 years of triangulation process here we use. This is a kind of abstracted view of those contextual pressures I'm talking about. The actors in the middle are designers, builders, legislators, building users, facilities managers, occupiers, everybody who is engaging with energy in buildings and who has ability to affect change in energy consumption. There is a formal set of guidance that they sit within, made up of directives, regulations, certification, etc., and then an informal set of pressures, which are their aims, their kind of aims for engaging with energy, benefits they see in it, risks, disbenefits, barriers. And this is, I don't expect you to be able to read this, but this is a kind of Gantt chart effication of that abstract. So that's the RBA work stages across the top. This is the actors who might be involved in those stages. Is this going to granddad's slide projector lets us down? I can't read any of this. The formal contextual pressures are here, the building characteristics determined here, and then positive group forms here. The thing to take away from the slide is who might be involved, who might typically be involved in the design process or the management process or the decision-making process about buildings as we move through the stages into operation. What metrics and bits of legislation apply at each stage, and when building characteristics are determined. So we could see that we're looking at kilograms of CO2 per square metre building regulations. There might be an engineer, sustainability consultant, and an architect involved. And then over here we're looking at pounds per kilowatt hour, cost per kilowatt hour with facilities managers here. This lot have decided building characteristics. This lot have to deal with the consequences of it. They're not working to the same metric, they're not working to the same information, they're not working to the same goals even. There's a disconnect across that, and that's one of the things I was investigating. soft landings is looking at addressing this, but what we wanted to see was how that impacts on energy consumption in the longer term. So I got 4 or 5 slides on the survey, each picking out kind of pretty headline findings from my work. This looks at how important people thought energy and how important people thought carbon emissions were when you're making decisions, design decisions or other decisions about how they run buildings. I don't expect you to read this or look at that, but I want you to see that there is a difference between who thought carbon emissions was important and who thought energy was important. The point was that between designers, architects and engineers, there was a significant difference running a Pearson's correlation test that showed there was significant differences within design teams about how important they thought carbon was and how important they thought energy was, and there was a significant difference across building teams generally, so between designers and other people about how important carbon was and how important energy was. This was also applied across other more obviously different things like architectural design. Obviously the architects thought it was more important than services engineers, and services engineers thought energy was more important than contractors. Contractors didn't seem to care about much. But that's fine, it's not their job to care about these things. So what this identified was a significant lack of coherence in design thinking, a significant lack of coherence in what people thought was important in processes within design teams and within project teams generally. Next, we looked at how people determine energy targets for their buildings. I'm not going to go into this, is again a headline slide to talk about the most important thing: mandatory targets, client goals, planning requirements, familiarity with things we've done before. This is not an industry bristling with ambition when it comes to energy. They're waiting for people to tell them what to do, and then they're doing it. And the implication of using mandatory targets is you end up using mandatory calculation methods. You put together compliance calculations, don't look at energy in a fuller picture. So there's already been built into the performance gap the way people are looking at energy in the first place. We also asked who's collecting information, who was looking at why they were doing that. Only about 20% of people were regularly collecting any information. They were doing it to improve future projects. Again, meet legislation, meet reaching targets, and reduce costs. So again, meeting mandate, costs and targets were. Carbon emissions were way down here, despite being the kind of main frame of the building regulations. And knowledge transfer, actually learning things, were pretty low on the agenda too. Final slide on this is about disincentivization, which is energy information, feedback information. Why aren't people collecting this stuff? Most people aren't collecting it. Costs to organisation, costs to clients, not seeing the benefit. The key thing on this slide is client cannot see the benefit was seen as a large barrier to being able to go out and collect this information, whereas respondents' organisations not seeing the benefit was not a large barrier. So to me that suggests people, and this was confirmed later in the interview, people who could see the benefit of doing this but couldn't persuade other people to do it. There's a key role for energy information, showing the benefit of doing this stuff to other people so that you can persuade them that it's a good thing to understand. We need to understand how this building works because there is a benefit to you in doing this. People weren't able to explain that to the clients or to the building users, and therefore were unable to do it. We're unable to persuade them to pay the money to do it, unable to persuade them to invest in the infrastructure to get the information out of the buildings. I've got 2 slides from the Carbon Buzz database. This is the Carbon Buzz database as of June 2013, so the information in it was quite low. It changed now, I understand. I haven't seen it since June 2013. These are the 20 or so buildings that had comparable design and actual electricity and heat consumption data. The green is total energy consumption, red is heat consumption, blue is electricity. Design predictions on the bottom, actual consumption on the top. That line up the middle, which you can see. So a 45-degree line up there would be an equal design versus actual energy prediction. You can see that the total consumption is all well above that. The electricity is all, again, well above that. The heat consumption is kind of sits about 50-50 above and below the kind of equal line. There's a number of reasons for that. Most heat consumption energy is regulated, so most of it's included in the design calculations. Although what this suggests is nobody really knows what's happening with it once it's built. The electricity consumption, a lot of that is unregulated, equipment loads are unregulated, so there's an automatic uplift on the y-axis of equipment loads and all the other things, unregulated energy, which automatically moves that up that direction, although the relationship, the R factor, shows a kind of linear relationship between design and natural electricity, which isn't there in heat. So people have arguably a better understanding of electricity consumption than they do of heat, but neither end use suggests people know what they're doing. We then looked at projects with disaggregated information. So people that had made energy predictions on a disaggregated level, an end use level, so energy predictions with equipment and appliance levels, this sample contains. So there are 8 projects in the database at the time that people had made energy predictions with electrical equipment and appliance levels. We looked at how that compared in terms of understanding what's happening in buildings. I'm going to pick out 2 projects. The mean values are about, if we look at total, the mean is about twice, so the design to actual is about 2-fold increase in projects where people have tried to make a very accurate prediction of end-use energy consumption. We pick out 2 projects, so the worst and the best headline performers. We can see that in both cases, there's about a 3-fold increase in headline energy consumption in project 2, but the proportions are quite different. And a project that superficially has a kind of accurate energy prediction, I think this is cooling has kind of trebled, and lighting or heating has kind of, there's a third. Yeah. So even in buildings that look like they've got a decent energy prediction, they don't, nobody really knows what's happening. And to go back to feedback, using this information to help us make better decisions requires some understanding of why that's happening. What isn't captured alongside, or wasn't captured alongside this information, was an understanding about what's happening in those buildings, why that change has happened, so that we can really interrogate that data, understand what happens with the heating bills, including those. Is there more people in that building? Is the fabric better than we thought it was going to be? Is the airtightness better than we thought it was going to be? The construction methods had an impact on that. There wasn't that information to support that data, so we were able to interrogate that further. So we looked at some benchmarking out of that, but there are very few numbers in there, so it's not of much value, but to say something, it's not really, there's little value. So finally, we looked at some interviews. I'm not going to go through all of these because I'm probably going to run out of time. But to supplement the energy and survey data to understand exactly why this was happening, we did, I think, about 30 semi-structured interviews with industry about why people are not engaging with energy, how they are engaging with energy, how they're making predictions, and what they're trying to do with it. I'll pick out 2 quotes. One, this is a fairly horror show example of industry practice. SBEM used as a design tool. This is not going to result in anything close to a good prediction, but this is what happens when people are using mandate as their only form of forming an energy target. We end up using SBEM as a design tool, and actually in this case it's used as a costing tool. Sitting in a room with a QS, messing about with SBEM until you've got the cheapest way of meeting compliance. The bottom quote shows a kind of general tension in industry about what people want to do. They know it's a good thing to go and get feedback out in buildings, to learn about it, to understand how their buildings are working, but it's a double-edged sword. It could be brilliant, or a client could turn around and say, well, hang on, you haven't given us the building we paid for. So there is kind of benefits and barriers there, and the barriers are currently winning, and we're here. So to summarise headline outcomes from that PhD work about the role of information feedback, and these are probably generic enough to be incredibly banal and obvious because they're headline based, but energy information has to create value in itself. The value has to be apparent in the information to persuade people to engage with it. There has to be a reputational benefit from doing that. That might be the value that we associate with it, but the value has to be there. It has to demonstrate how the risks and barriers of finding this information out, finding out that a building doesn't work properly. It has to show why that's a good thing and how there's value in knowing that. Policymakers have to engage with it to alter the contextual pressures, and then it has to support different kinds of actors. People who are already doing this have to be able to then be advocates and show how this is a good thing to people who want to do it, like that engineer, but feels there's barriers involved in it, and then the value in that, the kind of market will drive uninterested architects to have to engage with this, and they will have to recognise that value and see it. So, I then thought about energy. That's all very well. How does that affect other broader categories? Working now in industry, this is typical workplace, how do we get these people to think about energy? And then I looked at this World Green Building Council report, productivity, well-being in workplaces, typical building operating costs, and this is for typical kind of office-based operating costs. We have staff costs at 90% of operating costs, rental costs at 9%, and then energy costs at 1%. So this energy information has to do something pretty magical to get people interested in it before they're going to look at that, rather than look at the staff costs. So going back to the ice house, thinking about the fact that it's a zero energy building is incidental. The fact that that building supports a culture and a community, a society around that economically, provides employment, provides some biodiversity on the roof, all these other kind of sustainable issues. The energy is kind of incidental to that. So perhaps we can look at sustainability from a wider point of view, rather than just energy, but use the sustainability as a lever, the productivity and the social benefits of this to kind of drive down the energy and part of the information that we put across. So we're going to move on to talk about what we do at AHMM on this basis. We have about 15-20 minutes to that. So what AHMM do is they're general architectural practice. We do all kinds of buildings. These happen to be the buildings we finished in 2013. So there's some cultural buildings, arts and cultural buildings in the top left, some schools, some residential, some office buildings, some kind of industrial things, and then a prototype that I'll talk about more in a minute. But what we are doing, they have a long-standing sustainability toolkit which has been running for about 5 years. Since I've joined, I have been implementing post-occupancy evaluation on all of our buildings to supplement this, to get information back into our processes in a way which is of value to us, is of value to our clients, and of value to our kind of industry wider. I'll talk you through what the sustainability toolkit does. It is a way of assessing our buildings, our design processes, our aspirations for every project at every RIBA work stage. So we did it at stage A, B, C, D, E, F, G at every project in theory. We're currently redesigning this to align it with the new RIBA work stages. But it works on 3 categories: carbon, people, and ecology. So spreading it out from just carbon, which is looking at operational energy, transport, renewable energy, climatic design, embodied energy, and waste. So even in carbon, we're looking at 6 different things on just operational energy. People category, we're looking at amenity and community, occupants, how our architectural decisions affect occupants, safety management and accessibility. And then in ecology, we're looking at water, materials and biodiversity. The output of this is what we call a rose diagram. It's a 12-pointed bar diagram and is on a 4-point scale from red. These colours are actually amber, light green and dark green, believe it or not. And it is round rather than elliptical, but what that gives us is a very easy means of getting information back to our design teams, back to our internal communications, to communicate to other departments and to communicate outside our practice on a very simple 4-point scale. We've done about 150 of these over the last few years, and we're going to supplement them with post-occupancy evaluation work, as I said. I'm going to talk a little bit about some post-occupancy evaluation work we were doing on our office and how that information is going to be used through this toolkit. This toolkit gives us a framework to talk about these 12 different issues, energy included, how we implement that and improve our design process through that. So the first one is this building here. And I've included this as an example of the kind of power of a really simple diagram. This was a master plan for a local authority for some social housing in North Britain, shall we say. It's about 150 residential units. We drew this after analysing this project at a design stage about what we thought was good and what we thought we could improve about this building. There's a big red bar on transport. There's a big red bar on transport because our aspirations for transport in our internal design guidance is to have lower parking provision, lower car dependency than the local authority thought we should have. We showed them this. They panicked at the fact there was a red bar on a chart. We'd drawn it. We just took it to them, showed them, said, look at this, it's red. They panicked. They said, why is that the case? We said, well, because there's a lot of car parking in this. We could reduce this red bar if we introduced some car club spaces, if we provided provision for people to cycle more, if we made spaces where people could get store insulated boxes so they could store their internet shopping safely so they didn't need to get the car. And they kind of went away, came back to us, gave us dispensation on their policy to reduce this red bar down to orange, simply because we'd taken a red bar. And I'm showing this because this is the kind of power of a really simple graphic, really simple information, even if it is just drawn in our office over a cup of coffee and a conversation about what we're doing on a site. It has the power to change how we do, influence what we're doing, influence other people, policymakers. So, I'm going to talk about 3 examples of other more tangible buildings we've done. This is the Angel building in Islington, you may recognise it. This was completed in 2009, I think, maybe later than that, maybe 2009. But it was a 1970s building. We stripped it back to the frame, we kept the existing frame, so we were looking at the embodied energy of this building. We extended the floor plates, put a new facade on it, and created a piece of office piece of kind of high-spec office that in a space of London which didn't really traditionally have high-spec office. It does several things like engaging the thermal mass and light purging the spaces to try and cool it. But our internal sustainability toolkit looked like this at an early stage and looked like this in the finished building. I'll address the red bar immediately because it's there, and like the council, we're going to panic. The red bar on occupancy is because of daylight factors. So the red bar, in terms of our internal ambitions, the red bar is doing the bare minimum we need to do to build the building. That's red. That's not ambitious enough to be anything other than red. So the finished building has got a pretty deep floor plan. Daylight factors are meeting BREEAM and CIBSE guidance. We did take other measures to put some intelligent lighting in there, change colour throughout the day to make people feel a bit better about themselves, but by our measure, it's a red. What I'm interested in talking about is the embodied energy in this building. So early stage, we thought, oh, embodied energy, we could do a bit more on that. We made it light green later because we used that conversation to take this, despite the fact we were keeping a frame, keeping the embodied energy that was already on the building. We were building a lot new, putting in a lot of new concrete, so we used this as a tool to kind of beat the contractor over the head as a design build process and up to the recycled content of concrete. Through a simple diagram like this, we managed to get up 40% PFA into the concrete at a time, and that was quite an unusual specification through this diagram. We then done a little bit of work looking at our assumptions on that. We thought we were light green because on that toolkit review, we thought the concrete represented, we thought building regulations, sorry, this colours in this are really not very legible. So this bar here is part L calculation, operational energy calculation in years of embodied energy inherent in the existing frame. Does that make sense? I'll take your silence as yes, absolutely. So we thought at building regulations this would have, there's 13 years worth of energy, operational carbon rather, in the existing frame. The energy, the data we've subsequently got out of the building means there's about 9 years worth of operational carbon in the frame. This building uses a biomass boiler, which means actually in terms of energy, there's only about 6 years of operational energy in the embodied frame. This is using assumptions of the ICE database to work out the embodied energy in that frame. I'm showing you this because our toolkits, we thought, so we thought we were doing pretty well. We're not doing as well as we thought we were doing, but that we can adjust the metrics that we're applying to that toolkit based on this information. We can tag this information to those other toolkits in our in-house searchable database so people know why that has changed, why the metrics that we're using for embodied energy are now changed, and the standards we're applying and the ambitions we're applying to our design work has changed. That's the kind of new recycled concrete inside the atrium of that space. Second project we're going to look at is our own office, which we have finished last year. We've been in it for about 16 months. So I've only been there since January, obviously. We've done a lot more work on this, a lot more post-occupancy evaluation, a lot more energy analysis of this building. It is a BREEAM outstanding building. 2 floors. The 4th floor is an existing building. Top floor is an additional add-on. Both are wrapped in insulated render. The lower floor is the continuation of this brick warehouse, so it's a heavyweight interior. The upper floor, for reasons I'll go into later, is a lightweight frame on top of that, so we've quite different environmental standards in there. And there's a roof terrace above. This was just as the construction was finishing, so the scaffold is still up. There's external blinds, so our climatic design conversations in our toolkit. Now we've got movable external blinds in those large windows. We've got very high floor-to-ceiling heights, 3.5 meters in the upper floors to get daylight deep into the spaces. And the spaces, look at this, the kind of social and amenity spaces were important. Our previous office was lots of cellular spaces all over that building. What we wanted was a space where we could all get together, talk about things, make things happen, so we've got lots of social spaces in the building. And as anybody who has seen a Hollywood film portraying an architect knows, the building is white inside and has scale models on every surface. And people stand around chatting mentioning. But what this demonstrates is that the embodied energy of this building is reduced by the fact that it's a recyclable material. This frame is bolted together rather than welded together. It's dismantled. We apply the cradle-to-cradle approach to the design of that upper building. The external facade is made of a stick system which we can take apart. We're monitoring the temperatures in the south and north facade of the building, so we understand what's happening in there. The only real material we had to work with, because it's also a very loose fit building, there aren't very many finishes, the idea being we can adapt it very quickly. It's an adaptive building. It can be an office today. The building itself was a sweatshop 20 years ago. It was a warehouse 30, 40 years ago. It's an office now that will probably be something else in the future. This building, this design allows that to change. The energy investment in the actual fabric allows this building to change. The only thing we had to work with was really the kind of finishes, the paints and things, and the raised access floor. This is 3 design roses for this building. I want to talk about materials. We were at kind of amber at early stage. We went down to light green and then we came back out to amber at a later stage. That happened because we were trying to apply this cradle-to-cradle approach to this building. We couldn't persuade our client, who is our landlord, who is also the client on the Danger building, Durban, London. There's a kind of cost uplift in finding an encapsulated floor that was a cradle-to-cradle floor. But we had it in at one point and it came back out. So what this toolkit realised us to do was be kind of critical in our approach to our own design, but record and track changes throughout the design process. And backing that up with information and data is a good way of doing that. We know this building is much better than our previous one because we've done a bus survey on it. This was our previous office, kind of fairly middling. This is our new office, all very good. Apart from this is summer temperature, air in summer, and temperature in summer. It's a naturally ventilated building. People open windows, it's 30 degrees outside, it's going to be more than 30 degrees inside. But we've investigated that. So we took our bus survey, we thought everything's pretty satisfactory. We were concerned about storage, we were concerned about desk space, noise, with big open space. They were all okay. It's temperature. So we looked at the design parameters. Winter, 20 degrees plus or minus 2. Summer, not exceeding 25 degrees for more than 5% of the time. 28 degrees for less than 1% of the time. It's not very legible. This is a summer week, which we carried out the bus survey on this day. This is 25 degrees. This is 28 degrees. There are yellow bars on this which show the working hours, but the working hours rather correlate with this is 9 a.m., that's 6 p.m. We're getting up to 30 degrees most days by lunchtime. It's hot in summer when the external temperature is also up to 30 degrees or something. This is a kind of pie chart of that, looking at a winter week, a spring week, and that same summer week. The left-hand column is the winter criteria, so time, operating time that are between 18 and 22 degrees in green. When it's above 22, it's in red. So in winter, we're about a third of the time within our design target comfort envelope. The rest of the time we're above. This column is green is below 25 degrees, pink is between 25 and 28, red is above 28. So in winter, the fifth floor, likely half the time we're below 25 degrees. The rest of the time we're above it. However, we know through the bus survey, people are comfortable. We have other feedback processes in our office that mean people are comfortable in this space. So what that leads us to question is the comfort targets we're designing to. And I'll talk about projects in the future that we've applied different comfort criteria to reflect this. One thing we looked at is, are we overheating this building? Are we using too much energy in this building? Why is it so hot? People don't seem to mind the temperature apart from in summer. We looked at our design criteria for energy, so our gas was looking at 55 kilowatt hours per meter square. Electricity was much lower, but didn't include any equipment loads. There's no figures on these because we didn't film or control where that information goes, but I'm happy to discuss this later. Our design target was this, our total office is this. Fifth floor is up here, blue is electricity, red is heat. Fourth floor is down here, and our pre-move, this is kilowatt hours per meter square. What this tells us is our heating loads are much lower than our design targets, but we hardly have heating on at all, despite this temperature. We've insulated the building, we've packed it for the people. It's about one person per 6.5 meters squared. At the moment, there's a lot of people in there, and there's a lot of equipment in there, which is why the electricity is so high. Fifth floor has a server room on it, so that's why that's 3 times the amount of the fourth floor. But I'm not understanding that. Without looking at this, we don't know. So what we're now doing is implementing a full-scale submetering to understand what all this equipment. Everybody's got 2 monitors. We're 1 6.5 per square meter. There's a lot of people in there. If we can understand where all this information, this energy is going, we can try and get down closer to that. Although that didn't include any equipment, so we're never going to get there. But this is information we put into future design reviews, future toolkit reviews, and use it to inform our energy predictions. This is a quick scattergraph of using CO2 in the building as a proxy for indoor air quality versus temperature. You see temperature, this is 3 weeks again. It was the winter, spring, and summer week. You see this in odd shape. The temperature, CO2 levels get up to like 1400 parts per million, 1500 parts per million. And the temperature gets up to, well, over 30 degrees in the summer. What's actually happening is, if we highlight, this is a winter day, people come in, temperature starts to rise, as the CO2 level rise, and at about 26 degrees, somebody opens a window and then dissipates some of the CO2, but the temperature's already up there. Similarly, in spring, this is the first day in the morning, the temperature rises, CO2 level rises, at about 26 degrees, somebody feels uncomfortable enough to open a window, dissipate some of the CO2, and then the temperature stays up there. Summer, when the windows are open all the time, the CO2 levels are down at kind of atmospheric levels, but the temperature just goes up. So we're using this information to make people engage with these. How do we make people to open windows? We're implementing some feedback systems that connect to these phones and their internet to make people go out of their seat and open windows at 24 degrees. We're also looking at how we engage thermal mass in this building. This is a night where the cleaners shut the windows at about 10 o'clock. See the temperature stops falling and goes back up as the slab starts to dissipate heat into the space. This night we persuaded them not to shut the windows and the temperature dropped. So there's kind of a 3 or 4 degree free wind just by engaging the thermal mass. The reason the cleaners shut the window is because our insurers won't allow us to leave them open. So we're currently in negotiations with our insurers about changing our policy to leave our 4th floor windows open. And we don't think people will carry much stuff out there. So, engaging that thermal mass. We're looking at implementing feedback methodologies to do this. This is looking at our costs, our operational costs, percentages of our operational costs. We have our payroll in the middle. This is blue and red is pre and post move. So blue is before we moved into an office, red is after. Payroll is only about 60% of our operational costs. Other things are about 35%. If we compare that to our one-off build costs, they're about 30% of our operational costs. Our rent is down sort of 5-4% of our costs. Our utilities costs, so gas, electricity and water, going back to talking about getting people interested in the value of energy information, our utilities costs in our new building are 0.2% of our operational costs. I asked the commercial director about how how we can go about reducing our energy consumption, he said, I'd rather reduce how much money we spend on fruit because we kind of do a bit more of that. So energy is pretty low on priorities. But gathering this information helps us understand what's happening. And that's kind of reinforcing the point that all this stuff is nice and it's there to make these people work harder and work better and be more productive and be happier. And if we can frame it around that productivity and that sustainability aspects, then discussions about the architecture become something else. It becomes more focused on what people are doing inside the building. And this is a bus survey productivity swing. So this is a pre-office, new office. The perceived productivity value in the bus survey, we think there's been a swing of about 10% in productivity by moving into our new office. How do we know that? I don't know, but it's as good a measure as we've got. And that's finally on that, some of the social spaces we've got which kind of make people feel more productive and make people feel happier in those spaces. So that has thrown out a lot of information about how we design buildings and what standards we apply to buildings. This is the final few slides I'm going to show. This is the white collar factory, which is currently on site on Old Street Roundabout. This is of a similar suite of buildings. We have been working on what we call the white collar factory principles. Our office is one of them. This idea of a loose fit building. The idea of Victorian factories are still in use today. They're adaptable, adaptive buildings. If we can build new ones of them, these buildings should be around for a long time, similar to Victorian warehouses. So the principles are high ceilings, so 3.5 metres, we showed that in our previous building. That allows daylight to penetrate quite deeply, gives some stratification to the air, although not enough, as you've seen in the previous temperature. Graphs. We're applying concrete core cooling to this building, so rather than just exposing the thermal mass like we did in Angel and like we did in our office, we're actually cooling the slabs of this building to increase the capacity for pushing the temperatures down. Windows are open, we're still applying that principle of openable windows, adaptive thermal comfort, but in this building we have developed with our green screen, which shows people when is a good time to open windows, when they're going to be fighting against their systems that are in the building, the concrete core cooling, for example, and when it's a kind of neutral thing to do. So we're applying that learning from previous buildings via our toolkit into this building. Flexible occupation, that's the idea of loose fit, which I talked before, and stays cool and stays warm. We are designing this building for a comfort envelope of 24.5 degrees plus or minus 2, because we've seen in our previous buildings and other buildings that people are happy there. They seem okay. They seem to be working quite well. Designing to 18 to 22 degrees is very difficult when you've got a highly densely occupied office, but also people are kind of functional and more productive, we think, at higher temperatures. We've also modelled this building, the idea of loose fit and adaptable building. This is also an adaptive building. Empirical modelled this to various climate change scenarios, to 2 degrees, 4 degrees climate change for the next 60 years. So this building should work to a comfortable level, plus or minus 24.5 degrees, plus or minus 2 degrees in 50 years' time if the temperatures go up by 3 degrees or 4 degrees. So we're applying that information via our kind of framework of discussion on our toolkits to new designs. However, this is about influencing design, influencing how buildings get built through information. This is the white collar factory prototype. We found that all of the information, all of the Rose diagrams, all of the graphs, all of the tracking information wasn't enough to convince people that this is a good thing to do, so our client had to build one. We had to build one to convince agents that this was a building that was going to work, that was going to be sellable, and it was going to be a desirable thing to work. So we had to build this, put people in it, and then they went, got it, let's do it. So the idea of information just being data, just being graphs, just being pictures, it's not. Sometimes it's full sensory information about actually getting inside something, experiencing it, understanding it, and then having the confidence to say this is what we're going to do. So, I think I've been given the very well timed nods. So, just to summarise, from my PhD, I was looking at kind of how information has to be applied to different people in different ways, at different stages, to convince them of doing things. At AHM, they have a long-standing kind of method of doing this. What we're now doing is supplementing that with post-occupancy evaluation information as a framework for discussions in our design process to make better buildings and better decisions about how buildings work. I think I'll leave it there, actually. Thank you very much.
Right. Questions for our speaker this evening? A whistle-stop tour through one practice's approach to designing cutting-edge, low-energy and convivial spaces. Questions, please. Could you give your name? As you
Sarah, I'm an ex-student here. I understand that this diagram uses more in design stage. What's the percentage that really follows through construction? I understand that's the point to go.
So we use it at every stage. So
we use it
during construction. It's a good way of, even during the construction process, where there isn't necessarily a lot you can do, there's often a lot of value engineering that's happening. So using this as a framework for conversation about what we can and can't lose in terms of cost savings is a good way of reminding yourselves and reinforcing our position in those conversations. And then we're using it at post-completion stage to understand what happened in the building, and then we're using that to set up the kind of post-occupancy.
So this is something you discuss with the clients beforehand, that they will have like monitoring equipment there and you'll be collecting data.
That's what we're beginning to do now. Yeah.
So the majority of the buildings you can manage to get the client to accept that all
well,
this.
We're just beginning to do that process now. So
okay.
Often the energy, as I said, and my quote from Harry Broom, is often the equipment to collect the energy information is already there. So if we want to go and do a bus survey, we'll do some other supplementary collection. What we're typically doing is we've set up an HMM BPE protocol, we call it, which collects a substandard set of data from buildings. We get that, look at it, and then if there's anything we identify in that which is of interest and we think will be valuable to our client, we then put it to them. We would like to come and do this, and then we have that negotiation.
Hi, I'm Steve Pretler from Kingston University.
Hi.
Thank you, that's really interesting. I'm also interested in a similar sort of area, which is to do with the metrics that you're using in the toolkit. And it raises a number of questions which I think are quite interesting. I suppose the first is that you've developed a system, even though there are a number of existing systems available to do these sort of assessments, most of which have something like 9 categories. You also have 12. So why generate something sort of more complex when there are systems already there? I think I probably know the answer to that, but the real question is, they appear to be equally weighted, the 12, or are they not? Because most other systems, certain aspects of those systems are...
they're independent of each other. So there's 2 questions there. Why develop a separate system and the weighting of the group? So start with the second one first. They're independent of each other. So there's no, the red bar on transport has nothing to do with the green bar on grid. So they're not weighted. They are independent things. The underlying metrics we're reviewing at the moment, but the kind of nice thing about a graphic display, the outer ring of which being minimum compliance standard means we can change the metrics and always kind of push our ambitions by increasing the level we're trying to aim at. And if metrics change in other systems, then so we can deal with that. Developing a separate system, what we don't want to, and this goes back to my PhD research, we don't want this to be a compliance metric. This is not a tick box exercise where we say, okay, we need to get down to amber or everything, let's get there. This is a design tool, it's a workshop, in-house design workshop, often with other consultants, often with the design team or a client, and all the better if that's the case, but it's a design discussion. It's not designed to get credits for anything, it's just designed to help us push ourselves internally to get better. So it's our own thing, independent of everything else, as well as a separate system. Although, interestingly, in 2014 BREEAM, there is an ENE04. There are a couple of credits available for passive design analysis at early stages, which we're testing whether this process is a viable way of getting credits. So this in-house process can actually get us BREEAM credits on our buildings, which is, I think, another justification for our separate system. Does that answer?
Yeah, no, that does. Yeah.
Hunter.
Going back to the first question, how do you make builders do what you want them to do? That's seems to be one of the trickier parts of the process.
How do we make the builders do what we want them to do? Yeah. Well, I mean, we're in those cases, as I say, I've been at the insurance since the start of the year, so we are kind of relying on your standard contractual ways of making builders do things. What this toolkit offers us is a way of, when we're talking about a builder approaching us to do something differently or to value engineer something, this is a good way of reminding ourselves and them about what we're trying to achieve and why we're trying to achieve it. So it's not necessarily using this to make them do something, but it's to remind us of what we're trying to achieve so they don't do something contrary to this. So it's not quite hitting them on the back, it's reminding us why we're hitting on the back.
I'm a current student at the Energy Institute. It seemed to me, and as far as I could tell, your research has been mainly focused on commercial and office buildings.
My PhD research.
Yeah, your research and I guess your current work as well.
No, we just haven't shown. So the buildings that were on the energy consumption data for buildings were a mixture of office and educational buildings. I happen to have shown you 3 offices here because they were seemed appropriate, but.
I was interested to see perhaps if it's applicable to residential buildings.
Yeah, absolutely. So, I mean, there's 12 categories. Occupants, every building's got occupants. So we have, I should say, we have the underlying kind of framework for which we use as a discussion for that design workshop. We have a number of versions of. So we've got residential, commercial, arts and culture buildings, healthcare. So we do have separate kind of matrices for looking at and discussing different types of buildings.
I'm interested, sorry, Roger, visitor soft landings, I'm also a student here. Now, I'm interested in how the practice is going to be using the BUS survey data to inform design decisions. You've done a BUS survey, you get a result back, what do? What's the decision that you're making that you would not otherwise make? Because as you pointed out, there's much more to occupant satisfaction than operative temperature.
Well,
and there's a wide variety of issues that contribute to occupant satisfaction.
Sure. So there were 2 bus surveys there. The first one was done in our office previous to moving. So that first bus survey informed the brief for the new office. So that looked at things like storage space.
So what did you do that was actually, what did you do that you would not otherwise have done because you had BOS data?
I don't know the answer to that. I know there was regular issues of storage and breakout space and kind of communal space actually was the kind of main thing that came out of the first one. There was nowhere for people to meet to congregate. So we've got that roof terrace, we've got that large refectory space, and there's lots of breakout spaces in there. As far as I understand that, but as I say, it's kind of before my time at AHM. But the new bus survey, we're using that to inform comfort in new briefs to kind of put forward an argument about extending the comfort envelope and showing what adaptive comfort is. And we're using it to implement an in-house feedback system, which, bear in mind, this building is full of people designing buildings. If we can use this, our own building to educate and inform them about comfort and energy.
Can I ask one substitute question? I mean, you're using feedback to inform design.
Yep.
How do you make sure that the decisions you make are actually bolted down? And it comes back to Hunter's point, I think. It's all very well making decisions at a design level and at a design stage, but you've got to make sure these things are bolted down throughout the vagaries of, I don't know, D&D, for example.
Yeah, no, it's a work in progress. We don't at the moment. As I said, I've been there since the start of the year. We're kind of trying to implement this stuff to reinforce the decision we made, make these things, for example, a natural ventilation design through a design and build process, make sure that's an important aspect of the building. I could give you lots of examples where things have been removed based on the value engineering design build process that means lower energy systems don't work as it should. Yeah, it's a work in progress. It's a good point.
Sarah Carson from CIBC. You mentioned you collected 150 buildings worth of data over the last few years, so data is a really hard thing to get hold of.
Yeah.
First question is, how easy, difficult was it to go back to the client and get the honest?
So the 150 project, it's 150 kind of toolkit reviews we found out. So they are an in-house process. So that's not going into buildings.
So that's not actually going to the buildings and getting the users kind of feedback. So my next thing was why or how do we get the industry? How do we get more information from buildings and the actual users after everyone's kind of put it up and disappeared off site?
Yeah, so that's what we're implementing now. We're getting into buildings now we're trying to realise the value of that information through our own building, through the Angel building, and a couple of others we've been looking at in a lot of detail. We're trying to express the value associated with that data to convince all of our other clients that we want to get in there and get this information out. Sorry, that wasn't it.
Okay. And then
Simon Foxton, the Architect's Practice. Are you proposing to share your sustainability toolkit with others in order that it can be tested beyond AHMM and you can achieve some benchmarks against other people's projects to see just how well it is reported on buildings?
Pass. I think it's an interesting proposal. We have internal, as I say, we've done 150 of these. We've got some internal benchmarks on offices and education buildings, the kind of buildings that come up a lot. It's an interesting idea to share. There's no plans to share.
perhaps that's something you can take back to the office. It's a compliment.
Yeah.
Yes.
I was also just wondering whether you're willing to share your prototype building as well. Let other people, and is it going to be something that you experience?
Yeah, so Arab we're doing
Because what a wonderful thing, I mean, as an academic and teacher of architects, I've often thought, when I'm talking to my students, how wonderful it would be for them to build a real full-size model of what they're designing just to see how awful it really is. Because the technology is not there. To have this prototype building and the possibility of going to actually feel and see and touch. Is it going to be something that's available to?
It's been bulldozed, unfortunately. So it was built on the site of the new building. So we built it. I think it was up in place for a year, so that Arab could do some monitoring there. And then in order to build the new building, we had to knock it down. So unfortunately, so the data's getting around the building itself.
So it's a bit like sort of these buildings at Allford that are built for a short period of time.
Yeah, no, that's a good point. Probably should have got in there and carted it off to some of the back gardens.
I'll take perhaps 2 or 3 more questions if there are questions. Yeah, Mike.
Hi, Mike Fell, I'm here at the Energy Institute. I'm really interested to know what your sort of fellow architects think about the the chance that now they're going to be more monitored in a sense. It's going to become more clear how well their buildings are performing. Are people interested in having that information, or is there a sort of trepidation that
there's a nervousness, certainly,
and it might become
obviously the building we work in is one of our buildings, so the project architect is in the building. And she's really nervous about me getting around and looking at things. And every time I go in and get more data, I take it to her first and say, look, it's really good. And she's kind of okay, and sort of get some reassurance from it. But yeah, you're absolutely right. There's a kind of nervousness about finding out about this in our building and in everybody else. There's nervousness about finding out about other people's buildings, perhaps people less benevolent than our own staff. Finding out and telling them that the building doesn't work properly. We're trying to overcome all these barriers that I identified in my research.
Rod again.
Sorry, just following on from that, it seems to me that if we are entering into this area of nervousness, and it's entirely understandable, we have to get into a mindset, or architecture particularly has to get into a mindset where they treat success and failure equally.
Yeah.
I don't think we're there yet. So burying bad news is kind of the norm. Celebration, certainly celebrating too early is what we're very good at doing, getting our websites up and winning our awards. But bad news can sometimes, is that we learn from bad news.
Yeah, absolutely.
So what do you think, how long do you think that's going to take for the culture to...
The culture in generally, or in our practice? Or
No, it's rude to ask about your practice, but I'm interested in your views about architecture generally.
I think we're trying to be as open as we can, trying to publish as much of this stuff as we can. So we're trying to be open. Culture generally, I don't know, I think it's about creating value in this stuff. And soon people realise there's the value and the reputational benefit in actually being engaged in this.
These things are really difficult, aren't they? I mean, if this was easy, I think we would have solved it some time ago. But I think you touched there on kind of the short-term damage to reputation that comes about from having designed a plonker of a building versus the long-term benefit to your reputation of being known as a practice that does actually learn from its experience. And given a choice between practices that don't learn from their experience and practices that do learn from their experience, I think on balance most of us would probably go with a practice that did learn from this experience. but that requires that you make mistakes as well as build successes. Does that sound plausible?
Yeah.
I mean, we're hitting this all the time in the Lolo Centre for Cultural Training, where you want to do research with people in construction, in the building industry, and they want us to do research with them, but they're hesitant when it comes time to publish the research, particularly when the results are ambivalent, as they almost always are. Show me, yeah, Hunter.
Just an idea. The successful ones you can do as individual case studies, and the less successful ones you incorporate into design doc.
Yes. So you average the buildings that don't work well, and you celebrate individual buildings that do work well. That's a really interesting idea. Has that got legs, Rob?
I didn't think about that. I think we need to celebrate true success. You know, I've often said to people that don't judge your buildings too soon. But when you give it enough time, you do judge it systematically, and you get a good result. That's when you should shout about the results and really make the building stand out amongst the crowd. That hasn't happened yet either. There's just this general celebration of buildings, whether they're good or bad, and we need to get real. I think there's one thing about the Rose diagram. Since I've got the floor. The thing about when you start pushing the envelope on these things, you're kind of getting innovative or going beyond best practice. And you can say we're getting credits for doing that, however you want to rank the credit in the system. But you're also increasing risk because as you go into innovation, things become fragile, things become a bit dodgy, difficult for builders to do, never done it before. So how do you also at the same time as pushing those bars up to the green or bring them down from the red, whichever way you want to look at it, just bear in mind that you're actually pushing things possibly to their limits.
Yeah. So my role in practice is as a sustainability specialist to administer this and push project teams to be innovative and make these things happen. It is their job to take their clients and persuade them that this is innovative or risky. This is something that's well worth doing. But that's about gathering the information to convince them of the way of doing it properly. And in the case of the white collar factory, they couldn't convince them without actually building one, putting them inside it. So that prototype exists exactly because of the innovation and risk seen in that design.
I'll take one more question. Who wants to have the last word? Craig gets the last word.
Okay.
So in that case, Craig, you have the last word.
No, I was just going to follow up on Hunter's point about averaging bad buildings and celebrating good ones. I think we need to also expose bad ones. We need to look at bad ones as well as good ones. I think a kind of slurry, sludgy median of bad ones is not helpful.
I didn't show an average, but you can disguise. You may have to work hard.
Yes.
Given the profile of buildings, but you have to judge.
But there is a Shakespearean quote, which is "There's nothing good nor bad, but thinking makes it so." And I think that's a really important point. There's just lessons to be learned from these books. We only attach them.
I would like to thank Rod, paraphrasing Rudyard Kipling, quoting Shakespeare. And I think there was one other there that I identified, and I can't remember anymore. So thank you for that. I'd like to thank Craig for a really interesting glimpse into what it's like in practice for those of you who are not practicing architects. This, I think, is what it looks like in practice. And I'd like to thank the audience for participating in so many questions. So thank you very much.